walk through the process of figuring out what you have. Do you have any zeros in the numerator? No. So our x-intercept is none. Our vertical asymptote, I have to set the denominator equal to 0 and solve for x, and I get a non-real solution. Therefore, do I have any vertical asymptotes? No. I check the horizontal asymptotes. Horizontal asymptote, I look at my degrees. Top degree is less than the bottom degree, therefore it is at?
Equals 0.
Y equals 0, very good. Now my top degree is 2 away from the bottom degree, so I will not have to worry about slants. So now it's a matter of picking points. So as I start to look at this, I have all the important information. The easiest thing to find to start with is going to be my y-intercept. My y-intercept is when, x equals 0. So if I set x equal to 0, I get negative 24 over 8, which is negative 3. So my first order pair, 0, negative 3. Now I'm going to pick a couple of points on either side. And just make it easy on myself. I'm going to use 1s and 2s. Since I'm squaring that, 1 and the negative 1, won't I get the same answer for both of them?
Correct.
Yes, ma'am. Top degree is smaller than the bottom degree. Okay. So if I use 1, I get negative 24 over 9. 2-ish? 2.5-ish? So 8/3. Plotting. 1, 2-ish points. Oh, that's 1-ish. It's convenient to have a thing that just moves.
So use it negative 8.
Thank you.
That's what I do.
At 2, I have 2 squared, which is 4. 4 and 8 is 12. Negative 12 divided by positive, negative 24 divided by negative 24 divided by positive 12 is negative 2. So it's a little bit above now, which tells me that it is working down and back up. And that gives me my curve.
And you know it doesn't have
I don't have an x-intercept because my asymptote's right is going through there, and I had no variables in the numerator. So you're right, I have no x-intercept.
and it has nothing plus.
Correct. Correct. That k value, remember, moves your vertical or your horizontal asymptote up and down. For when it was just x minus h. It's x squared, so don't follow that rule. Okay. What else we got? Yes, sir.
29.
X-intercept is at x, be at negative 1/4 comma 0. That's my x-intercept. If I write it as an ordered pair, it's fine. Vertical asymptotes. Yes?
Okay, you get the x-intercept by setting the top equal to 0.
Yep. Vertical asymptotes. At x equals plus or minus 1. Shimke's rocking on all cylinders.
Makes sense now.
And then horizontal asymptote my top degree is less than my bottom degree, therefore it is at
0.
y equals 0. Good. Make sure you guys say it's y equals or x equals for these horizontal and vertical asymptotes. Will we have a slant? Y.
Less than the bottom.
Very good. Now I have enough information to start. And we started this one during Flex with some of you guys. And this is one of the weird ones because you do have a jump through hoops, if you will.
It has then have 3 curves.
Yeah, it's possible.
So it doesn't mirror.
No, it could have
If
it.
it has 3, then it has 4. Would there be a mirror?
Well, wait a second. I think it'll just have the 2. I don't know. I have to look. I have to think of a problem.
Now you just gave me an idea for the wings.
I already ran it off, so I can't change it. Why waste the paper? Yes, ma'am.
So is your x integer -1/4 at 0, or is it?
The ordered pair. The x-intercept is at negative. Yeah, I'm just writing it into it.
-1/4 and 0.
So my x-intercept is at -1/4. Now, what I want to do is figure out some other points. Does everybody agree that this problem broke into three different domain areas? Okay. So we have to check 3 different spots. Well, the next super easy one to check is 0, the y-intercept. Right, the y-intercept. The y-intercept is when your value of x equals 0. So if I substitute in for 0, I get -1. Okay. Now, if you want to go further with that and go to a little bit more of a positive number, if you use, I don't know, 1/4, because it's a quick, easy one to work with a fraction. If I use a 4th, 4 times a 4th plus 1 is 2. 1/4 squared is an 8. 1/8 minus 1 is 7/8, -7/8. If I divide that out, I get -16/7. What's 1/4 times 1/4? 1/16. Sorry. So now I'd have -15/16. Yes, sir.
If there's a horizontal asymptote at y equals 0, then how can x
What happens a lot of times when you get to the upper degree polynomials with some of these weird jumps when the degree is on the bottom is bigger than the top, you wind up sometimes with 3 separate domains. When you wind up with 3 separate domains, it's usually your tails that are bound by the horizontal asymptote, not the in between. It's a pre-calc test. Okay, this is a nod and smile. It's also one of those things that sometimes you will wind up with. Let's say you had something that was factorable. Let's say you had something like that and we factored it all out. You guys would say that you had vertical asymptotes at plus and minus 1. But then all of a sudden these two would simplify out. So technically you only have one asymptote at 1. And then in the graph you have a hole at -1 if you curved that. So as you went through, you put a circle on it. It's kind of along the same lines. It's a pre-calc thing. We get really involved in these domain areas. What I'm just trying to get you guys at is plotting points. Okay, it's not a big deal. You will see in between domains that jump, and that's okay. It's the tails that will abide by the outers. So it wound up being like here-ish. So it's doing, should be doing something like this. Oops. Should be something like this, I believe. On the tails, then, if you substitute in, it winds up being cleaner. If you use 2 and 3, I think you get really nice points. At 2, you get 9 in the top, and then 3 in the bottom. So at 2, It's 3. I thought 3 worked cleanly too. Oh, that's right. It's 13 over 10. No, excuse me, 13 over 8. So that's what, 1 and 5/8? Should be 1 and 5/8 then? So should we be doing this? What's that? Yeah. I'll ask you for a couple points on either side. Now remember, a lot of these are goofy. Some of them are pretty clean. If I use -2, I get -8 plus 1 is -7. So I have -7 over 3. Whatever. So -2, -7/3 is what, 2 1/3? If I use -3, this would be -12 plus 1 is -11. -11 over 8. One and change. Should we be doing this? I think that's what it looks like in the graphic calculator.
Yeah. Are those two mirrors of each other? Yes.
There is some reflection there, but there's some weirdness that does occur, but it's not big. Yes, sir.
I got a problem. 30.
Wait, hold on.
Those are horizontal.
What's all this?
Who's in here taking my force? Some horizontal aspect.
Sure. You were saying, yes, sir.
How do you get the equals 9 over 3?
I use 2. What's 2 times 4?
8.
What's 8 plus 1?
So you just plugged in 2?
I didn't plug it in, I substituted. Yep.
You just choose the, like...
That's what we've been doing all along, picking numbers
I
up.
haven't been here.
You haven't been paying attention either.
I need to come in.
I picked numbers on either side of the asymptotes. That's what we were doing. I did that all day yesterday also. All day yesterday. But you were doing homework from the days before instead of watching what we were doing. Pay attention to what we're doing, bud. Okay? Oh, yeah, it's whatever. It's yours. Oh, speaking of calculators. I know. Uh-oh. Who still can't find their calculator?
Eric.
Crap. Is it possible that it's not lying around in your house that you think it is? Is it possible prior to you getting sick, you might have forgotten where you left it? On the charger? You know, it was cool. I finally today, that thing's been sitting on the charger for so long, I'm like, I wonder whose this is. I never even thought to look it up. And I think I might have mentioned it. Is anyone whose this is?
Yeah, he was taking his test though.
Oh, that's right. I said that you were gone and you didn't get to use a calculator on that part. So, found your calculator, my friend.
I think it's charged.
Yeah, I think you're okay. Yes, ma'am. Shh. Hold up, guys.
When we ask you, and there's a bunch of reasons, there doesn't, are there anything, or some of the regions doesn't do that?
Yeah, regions sometimes like regional, yeah, because you wind up with hyperbolas. Hyperbolas are going to be like this or like that, where they're not in other regions. That's all.
So, like, when you're picking points, how do you know which one it goes to?
You just pick, that's the whole idea, and that's why we're saying why do you pick 1 point versus 2. When you pick 2 points, when you're in a specific region, if you pick 1 point when it's up here and the next one's down here, and your asymptote's going this way, that means it's going to be doing that.
No, like if there's one on, like if you have an x-intercept and then you just pick another point, how do you know like which one goes to which point?
Well, what do you mean by like?
Like if you have 2 x-intercepts and then you pick like, they're like right next to each other and then you pick another point, how do you know which one goes to which?
Oh, it's for the y value?
Yeah, like which
That-
x goes with the y.
That's when it comes up to you. Here, I'm going to have x-intercepts that are going to be real. Do you agree on that? After I get that and I find my horizontal asymptotes, my vertical asymptotes, then the vertical asymptotes are going to be the ones that I don't choose. I'm going to choose ones near them to figure out which way the curves are going. So in this top one, I have to factor it. So I have to go 2x squared plus 2x plus 1x plus 1 to go through that. You group it. So you wind up with x-intercepts for the zeros of the numerator at -1/2 and -1. Our vertical asymptotes factor the denominator. We get x minus 4, x minus 1. So my vertical asymptotes are going to be when x equals 1 or x equals 4. Horizontal asymptotes, I look at the degrees. The degrees here fall into top and bottom being the same. Therefore, it is at 2. Okay. Now I have the 3 asymptotes. 3 asymptotes, 2 intercepts, and a y-intercept.
Yay!
Thank you, thank you. That was all. Yes, ma'am.
Okay, so if you have like an x in the denominator of the equation, you can solve to find the vertical asymptote by factoring.
Yes.
Okay.
You're highly encouraged, yes. That is something I would do every single time. Anytime I have an x in the denominator.
It equal to 0, but you can factor.
Well, yeah, that's what we're doing. I mean, sometimes it's just linear, but a lot of times it's factors. Yes, sir.
Are domains gonna be when y equals something?
What comes first in the alphabet, D or R? What comes first in the alphabet, X or Y?
So domains are gonna be all real when x equals something.
All real and X does not equal.
Yeah.
Everybody's having things.
Okay. First 2 asymptotes are in. Now we put our other one in. That gives me 3 reasons to check. I know that I have x-intercepts at -1/2 and -1. The next logical point to check would be my what? 0. My 0. If I use 0 for x, it's going to give me my y-intercept. So substituting in 0 real quick here. 1/4. So at 0, okay. Now, for some of you guys probably went through and looked at the calculator at this point, and this is one of those weird graphs that starts abiding here, drops, and zips up. I think this one does that.
Oh, it should be.
Okay. This one is a weird one because it does that. It does the jump of the asymptote. Don't worry about the jump of the asymptote. I get it. I get it. It's weird. You'll learn about it next year. There's no reason for us to go into it at all right now. Just take a deep breath, ladies and gentlemen. Okay.
I don't want to.
On the middle section, you pick 2 numbers that aren't the asymptote. I don't know. 2 and 3. Good choice. Thank you. Thank you for your support. At 2, I believe we just did this. It was what, 7.5? Was it 7.5? 2 was -7.5. No, that's 6.5. And then negative at 3, it was -14, I believe.
Oh,
So it was hugging and it was coming back and around doing that.
wait.
What?
Oh, would it just be a hole then where the negative or the 2 is for the vertical, horizontal asymptote because it goes through?
Yeah.
Oh,
Technically. Yes, sir.
How are you able to tell that it's going to go like that?
What happens is that you know that in theory, it shouldn't go up to there. So somewhere between here and here, there should be some maximum value. You were talking that intermediate value theorem. You could use the intermediate value theorem, which basically states that between too many values, there will be some maximum and/or minimum, and just start substituting values, 2, 2.1, 2.3, and figure it out, or just kind of bite the bullet and say, I know it's going to have to curve.
So like, it can't go past that because that's going to be,
Yeah,
it's like one of
the boundary.
How come that one can jump then? Why can't that one jump too?
It's due to the function. It's due to the It's due to the actual given value. There are things. What happens is that you wind up with values that can and cannot work. It does occur. What I want you guys to be able to see for something that winds up looking so unbelievably weird, could you tell me all the important parts? Yes. You can tell me where all my intercepts are. You can tell me where all my asymptotes are. You can tell me if there was a slant asymptote. You can tell me domain and range on this one. Does it have to be an absolutely perfect graph if you're not using a graphing calculator? No. No, it doesn't. So if I'm just looking at this and I don't even bother looking back at the graph, and I go and say, hey, according to your stuff, the things that you guys have done so far on this problem, we had asymptotes at, I forgot, 1 and 4? 1 and 4. What's my domain?
Everything
All
except.
except one and-
I mean, 1 and 4.
All x not equal to 1 and 4. Yes. What's my range?
All
y
All
not
except
is
two.
not equal to.
Okay. You're fine.
That's all you need?
If it winds up being something that it's going to be unbelievably difficult to graph without a calculator, that's all you're going to need.
On the quiz though, will you specify, I want just the domain and range, or I want,
Yes, it will be said, it will be shown. I will give you a piece of graph paper on the quiz if I want you to graph. If I don't want you to graph, you won't see a graph. So you're going to be a graph. Oh, it's all non-calculator.
Can you at least give us a cheat sheet for
No, but I think I might give you the dummy calculators because sometimes, -3 squared plus 4 is 12. What's that? Word problems, you have to use the calculator because those are all approximations with maximums. Thank you. I forgot to mention this. What I decided to do when I was going through the problems is that this chapter is so different between just sections 9.2 and 9.3 versus the rest of everything else. 9.2, 9.3 are really the only parts of this whole chapter that have anything to do with graphing. Everything else is factoring and simplifying, factoring, simplifying, factoring, simplifying. So let's just do the graphing today, and then we'll finish out the rest of the chapter, and then just go like that. So there will not be 9.1 on here, just be 9.2, 9.3. Okay? And really, if you look back at the 9.2 stuff, the 9.2 stuff, the only one that was different was this formula. The other one where it was the ax plus b over ax, or cx plus d, it mirrored the same thing as this with coefficient one. All right? That's it. Okay? I heard you say. Oh, that's right.
So you're saying that there's going to be no graphing on the test?
Oh, on the overall test? Oh, I don't know. I haven't written it yet.
Oh, I thought that was what you were implying. Because you said that would be that.
I was just quiz. We still got like 4 sections to go in the chapter. We'll be done with this chapter before Christmas stuff.
So we'll look at the last chapter.
The holidays. So is this the last chapter? Or is there any other chapters?
We still have another one to go. The next one's really fast, real quick. Okay? Jimky, what do you got?
Who are you 36?
Yeah, dollar?
Not on me.
It's 36. I think it's the first time I got a genuine laugh out of him, and it's where he's not like laughing at me, but an actual genuine laugh of something funny.
36.
Not my problem. I get it. All right, I give up. Start at the top. X-intercepts are, we got a factor. What times what's positive 20 add together, you get negative 9. So your x-intercepts are at 5 and 4. Vertical asymptote. 0 at x equals 0. Horizontal asymptote. None. What's the degree of the top? What's the degree of the bottom? Which means we have?
That's where. Oh, 2 divided by 9 is.
How do I turn a 2x into an x squared? 1/2 x, yep. I'm going to put in a 2x plus 0. I've got to put my placeholder in on that. So we have x squared minus 0. So I have negative 9x plus 20. How would I turn a 2 into a negative 9? Negative 9 over 2. Very good. And I really don't care about the remainder because it has no bearing into the problem. So now we have this, the equation of the slant asymptote. Remember, that's a y equals, so it's a good old-fashioned y equals mx plus b. And we go through our button. Vertical asymptote was at 0. The next one was at y equals 1/2 x. Was it minus 9/2?
Yeah.
So I start at negative 4.5 and I go up 1 over 2. That's, wow. That's really pretty. Wow. That's better. I forgot my intercepts. 5 and 4. Doesn't really help me a whole heck of a lot of how fast the curves or where the curves going towards and whatnot. We need to get something on the other side as well. But we know that they're in that top right area, and which means you should be in that bottom left area. Are we okay with that?
Yeah.
So let's just pick an extra value on the right. Let's use, I don't know, 1, 2. It's on the right. So if I use 1, I get 1 minus 9 plus 20 all over 2. So that's what? 12 over 2 is 6?
Yeah, probably.
So you get a little better idea. So it's probably doing something like this. Okay. Then you got to pick a couple points on the other side. I'm not sure if they're going to fit into this region, but you'll pick, I don't know, -1, -2, -3 in that area. Yes.
So for the quiz, do we only have to like find one other point besides the x interior intercept that you gave us? We can just assume that it goes along the.
That was the whole point of knowing, because we had the hyperbolas. They're going to hug the asymptotes and turn and go through.
We don't have to like define more points once we know which direction it's going in.
If you have just 2 points next to each other, you don't really know the direction.
No, but like.
Oh,
we
I
have
see
to
what you're
define
saying.
that, but we don't
Yeah.
have to define another one
You'll be
besides
okay.
that. We just
Yeah.
hug it.
Yes. And the same thing on the other side here. Okay. Do you want me to find those other values in the bottom part there, or are you gonna be okay substituting in? Please just substitute. Out of nowhere.
How do we do 31?
Like you did 30.
You should just gone all overall.
Haven't I by now? Haven't I?
No, we haven't. No, we haven't. That's it. 26.
X-intercept. Is that 0? 2x squared equals 0, therefore x is da, 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 0. Vertical asymptote is that x equals -2. Horizontal asymptote. None. Top degree is bigger than the bottom degree, but it's bigger by 1, so we're going to have a slant asymptote. So we check our slant asymptote, make sure you throw a placeholder in. 3x plus 6 into -2x squared plus 0x plus 0. How do I turn a 3 into a -2? -2/3 x. Very good. That'd be what, -4? Hey. 2/3, bless you. 2/3 of 6 is 4, so yeah, it'd be -4x. Subtract through. 0 minus -4 is? 4.
Wait, is it 4x? Oh.
Yeah. Chippy, you're right. I was just saying it.
No, you're okay.
Well, I don't know if I'm really okay.
Would it be negative?
Me hurts a little today.
Wait, what?
How do you turn a 3 into a 4?
4/3. 4/3.
I was waiting for you to say that. I knew you could do that. So there's our equation. I remember, you don't care about the remainder, it has nothing to do with the problem. So you've got your equation, you've got your asymptotes, you've got your intercept, you've got enough info to plot. X-intercept was 0. Vertical asymptote was at -2. Right? And then the other one was y equals -2/3 x, I forgot, plus 4/3. 4/3 is a smidge more than 1. Down 2 over 3. Down 2 over 3. It's the first one we've had where we had the other slope. Okay. You can probably see right now, since you've got the 1 point in here, which means the other one should be up in the top left. So if I have one at 0, why not just check it at 1? So if I go back and I look at it at 1, I get -2 over 9. So here's your hug. Check it at -3. If I use -3, I get -2 times 9 over -9 plus 6. -18 over -3. 6. And we'll use -4. -2 times 16 over 12. Oh, sorry, -12 plus 6. -32 over -6. So 5 1/3. So it's doing here. Zip. I have a couple that we haven't done yet. there's like 6 of them that we haven't done. The ones that I was going to say I would look at tonight, at the end of this section, there's this little quiz, self-test quiz for sections 9.1 to 9.3. It's on 553. These 6 questions we haven't done as far as the graph is concerned. Those are the only ones we haven't done. Try those. I mean, it's a good walkthrough. Be able to go through, do your domain and range, find all your intercepts, find your stuff. If the graph winds up being something that looks just unbelievably awful that you can't do without a calculator, then it's probably not something I'm going to make you do without a calculator. But yet, if it's something where it's 3 over x plus 2 plus 4, you can do that.
What page is that?
It's the same section. It's 553.
And what numbers do you want us to do?
7 through 12. Do you want graph paper or do you want to just sketch it?
Graph paper.
If you want graph paper, there's some graph paper in the back. Help yourself. If you want to sketch it, go ahead and sketch it. It's not a big deal. Okay? No, I wanted to make sure you guys had it.
Oh, bless your soul, Mr. Murphy.
Okay? Well, then stop by in the morning and check your answers. They put a bunch of them on here, right? Hey, what I'll do is I'll get these things sketched out for you, and I'll put them on paper, and I'll just tape them to the window in the morning. You guys can just pop by and take a look at it.
Okay.
Same section. Yeah, when we get to trig, I don't know. Well, none of you guys were up here. JC, you remember last year we did when you guys were coming to geometry? I had all those trig things written on the windows out there, all those proofs,
Oh, yeah.
all that stuff. I love writing on my windows when we get to that. It just looks cool.
1 through 12?
No, just 7 through 12. Yeah, because it looks interesting. It's really not.
I still write no.
We have one up. We haven't had any, nobody said anything funny about it because
Did you see
Yeah, it's not hard.
I know, me too.
you guys got questions. I'll be here in the morning. Swing in, okay?
So you don't want this?
No, I want to make sure you guys like.
Should we actually swing it, or do you just want us to come stop by?
I don't mess with this egg whites. That's what it works. It's just circular pieces of ham.